the first problems say to let f of x equal negative 3x to the 1/3 plus 4x to the 1/2, and g of x is equal to 5x to the 1/3 plus 4x to the 1/2. And so they give you like the f of x and g of x, and then the problems will just be like, what's f of x plus f of x? What's f of x minus g of x? What's g of x minus f of x? And it'll be stuff like that. So for this, like, probably these first like two problems, it'll be these values, and then we'll swap them for the next like thing or whatever. And it does say stuff about stating the domain, but like I said, we're just going to ignore that for the time being. So number 4 says g of x plus f of x. So what we do is we just take the first function and we add it to this one. If it's subtracting, which we'll do a subtracting one in a minute, but you have to be really careful about signs. So I've got 5x to the 1/3 plus 4x to the 1/2 plus, and then it's, I'm going to write it this way just so we can see it, but negative 3x to the 1/3 plus 4x to the 1/2. So since things are just being added, it's just whatever sign's already on it. So I could eliminate the parentheses and even the positive sign because it's just being added. But on the negative ones, like where it's subtracting, I would need to write it this way so that I get my signs correct. So combine like terms. So I've got 5x to the 1/3 minus 3x to the 1/3, and so that would give me 2x to the 1/3. Then I've got 4x to the 1/2 plus 4x to the 1/2, so that's going to be plus 8x to the 1/2. Now, we're not doing the domain part, but if we were, the domain of this would be all real numbers except for negative numbers. So basically any number from 0 to infinity would work, because I can't have a negative under the radical, which is what this would be, because this would be the square root of x, and I can't have negatives under there or it becomes imaginary. So, but like I said, we're not dealing with domain, but just so that you see what is happening with that. 8. G of x minus f of x. So with this one, I need to pay attention to signs because it's a minus. So I've got 5x to the 1/3 plus 4x to the 1/2 minus, then in parentheses, negative 3x to the 1/3 plus 4x to the 1/2. So still combining like terms. So now I've got 5x to the 1/3 minus a negative, so that's going to be plus. So plus 3x to the 1/3, so that's going to be 8x to the 1/3. And then 4x to the 1/2 minus 4x to the 1/2, so that's just 0. So this becomes 8x to the 1/3. And it would work the same way if it was like g of x minus g of x, then you would have the function and then minus and then the same function again. So anyways, just whatever it says, you just plug it in exactly. For the next one, so that was adding and subtracting, we're going to move to multiplying and dividing. They say let f of x be equal to 4x to the 2/3 and g of x is equal to 5x to the 1/2. So just so that like you're aware, probably to keep things consistent when we get to like the quiz or the test, I will probably tell you to find like f of x plus g of x f of x minus g of x, f times g of x, and f divided by g of x, or something like that, with the same set of numbers. So, like, I may or may not do it as two separate questions like these are. It may be, like, one giant question. So, it just depends. Some years I do it one way, sometimes I do it the other. So, but just so you're aware of what that would potentially look like. 14, I've got f of x times f of x. So this would be 4x to the 2/3 times 4x to the 2/3. So what does that give me? So what do I do with exponents when I'm multiplying two things together? Add the exponent. So what is that going to give me?
Oh, 4/3.
Yep, 4/3. And again, I don't really care about the domain, but the domain for this would be all real numbers, because there's no values that are going to cause a problem in this function. Let's see. 16. F of x divided by g of x. So this is going to be 4x to the 2/3 divided by 5x to the 1/2. Any ideas what I need to do here? Throwing it back from last section.
Change the denominator. We don't.
Are you talking about like this whole thing, or are you talking about just the denominator of the exponent?
Just of exponent.
Okay. Yes. Because what are you trying to do?
5.
Make them the same.
I mean,
Well, right.
Subtract.
Why do we need to do that?
Yeah. Oh,
You just
because
subtract it.
yeah.
Yes, because I need to subtract them. So which way am I moving it? Top to bottom or bottom to top? Which one's the smaller one?
Bottom to
So is 1/2 bigger or smaller than 2/3?
top.
Smaller. So I'm going to move smaller to bigger. So this is going to become 4/5. It's running away. So 4/5 times x to the 2/3 minus 1/2. And then you've already said it. We're going to get a common denominator, which would be what?
6.
6. So this is going to be 4/5 x to the let's see, over 6 times 2. So 4 minus times 3 is 3. So this becomes 4/5 x to the 1/6. And aside from negative numbers, because it's an even root, I don't have any issues here. If there had been left with x's on the bottom, then I would have to say, like, x couldn't be 0 or something like that, of whatever would make the denominator 0 for the domain. But I don't have that situation here. Are we okay with adding, subtracting, multiplying, and dividing for the most part? Okay. So I'm going to move to composition of functions. There's going to be like two different kinds of them that we're going to look at here. So they give us three functions. They give us an f of x, a g of x, and an h of x. And then there's different things that we need to do within that. So for the first ones, they say let f of x equal 3x plus 2. G of x is equal to negative x squared. and h of x is equal to x minus 2 over 5. So for 20, we've got f of g of negative 3. So this is one where I said they'll give you a number to plug in for x, and then you'll plug that into the function, and then we'll plug that number into the next thing. So I would say always start with we always have to start with the innermost, but I would plug in negative 3 into the function g of x first and get that number. Then that number is getting plugged in over here. So just looking at the g of negative 3 part for the moment, I am going to plug in negative 3 for x. So I've got negative times negative 3 squared. And what does that give me? What's negative 3 squared? 9, and then times the negative out here, so this is going to be negative 9. So notice the negative out here is not being squared. If there was parentheses around it, it would be, but it's not. So I've got that negative sign out front, and then I've just got the negative 3 that I plugged in being squared. So now this is this piece here. Okay, so now the next piece I'm going to do is f of this new number, negative 9. And so I'm going to plug in negative 9 for x here. So this is going to be 3 times negative 9 plus 2. And what is that?
Negative 25.
Yep, negative 25. Because we've got negative 27 plus 2. So these ones are much easier because there's a number to plug in, so there's never variables that we're dealing with. Like this is just plug in the number, super easy. Let's look at 26. Went up too far. This one is h of negative 4. So I'm initially going to be plugging in h of negative 4 into here, and then when I get that number, I'm going to plug it into h of whatever that number is. So this is going to be negative 4 minus 2 over 5, and what does that give me? Negative 6 over 5. So now I'm going to take that and replace it here. So I have h of negative 6 over 5 is equal to negative 6 over 5 minus 2 over 5. So what do I need to do to solve this? Or to simplify it, I guess.
So it'd be negative 6.
What do you want me to rewrite this as?
Negative 10 over 5.
Okay, yeah. So minus 10 over 5. So then you said negative 16 over 5, all over 5, right?
Yes.
Now what? So when I'm dividing by a number, would you agree that it's the same as multiplying by 1 over that number? So this is going to be negative 16 over 5 times 1 over 5. And that means the same thing as what I have written there. So this is going to become negative 16 over 25. So you can probably tell the ones where you're plugging in a number first, pretty simple. Let's look at a couple where there's no number to plug in, so we've just got to keep it as like a function into a function. So they give us new f, x, and g value, f, g, and h values. So we've got g of x is now equal to 3x to the negative 1. I lied, that's f of x. G of x is equal to 2x minus 7. And h of x is equal to x plus 4 over 3. So 28 says f of g of x. So now what this tells me to do is that I'm going to plug in the function of g of x, so the 2x minus 7, for x and f of x. So this is going to be 3 times, I'm going to replace x with 2x minus 7, raised to the negative 1. What do I need to do with this to make it so it's like proper? Like, what's the problem with the way it's written right now?
Negative 1 less than 1.
How do I move it?
Make it 1 over that whole thing.
Yep, 1 over that piece. So it'll, since I have a 3 there, it'll end up being a 3 on top. So 3 over 2x minus 7. And that would be your final answer for that one. So if this one had given us a value like these other ones did to plug in, like say it wanted us to plug in 3 or something like that, then what I would do is, like, if I wanted to do it at the end versus how we were doing it at the beginning, I could wait and plug in 3 at the end. And so then this would be like 3 over 2 times 3 minus 7, if that was the case. So you can see what I mean, where like sometimes it's easier to plug in the number first, sometimes it's easier to plug in the function and then just simplify it. So like you can do it either way, but most people tend to prefer plug it in first, like we did up here, if there's something to plug in. Let's do (32). H of g of x. So I'm taking my g of x function and plugging it in for h of x, or for x and h of x. So I'm going to have 2x minus 7 plus 4 over 3. So then I'm going to have on the top the negative 7 and the 4 become negative 3. So 2x minus 3 over 3. And people get tempted to cancel those 3's, but we can't because these are being subtracted on the top. So it would just be left like that. One more thing, just because people tend to struggle with this kind, specifically, is h of x. Now, the reason I say people tend to struggle with this is not because it's plugging a function, like the same function into this, like same function. It's because h of x is a fraction. So I'm going to have x plus 4 over 3 plus 4 over 3. The book is falling. So this is going to be written as x plus 4 over 3 plus 4 divided by 3. Any idea what I need to do first? are you moving this, or are you trying to get a common denominator?
Get a common denominator.
So if I change this to something over 3, how do I, like, I need this to be equivalent to 4. So yeah, 12. So like that. So now I can add the stuff on the top, so that's going to give me x plus 16 over 3 all over 3. Now I'm dividing by the number, so I can do the same thing I had done in one of those previous problems. So it'll be x plus 16 over 3 times 1 over 3, which is going to be x plus 16 over 9, like that. And then I would be done. So I show you that because people for some reason tend to get really confused about that and start just trying to like add things together, and then I don't even know where they end up sometimes. But anyways, that would be that. Any questions on this stuff? I know it's kind of like a lot, but it's really just like pretty simple algebra, to be honest. So okay. Then problems for this section are going to be 3 through 37, every other odd. So just as a refresher, because we don't do every other odd very often, it would be like 3, skip 5, 7, skip 9, 11, skip 13, so on and so forth for that. And if for some reason like 37 isn't like a number that would be included, if that would have been a skipped number, just don't worry about it. I didn't like go and count them all out, but 37 is one of the like describe and correct the error in their work. So anyways, and if somehow you get off track, like let's say you did 3 and 7 and then somehow you accidentally skipped like 11 and you did 13 instead, like that's fine. Like just if something happens like that, don't feel like, oh my goodness, I did all the wrong ones, and like go back and start over. Like that's fine. As long as you have like that quantity of problems, I don't care.